So welcome everyone. So as mentioned, my name is Chris. I'm a CTO at Grapher. We've been like developing and doing Neo4j consultancy for 10 years almost. Right. So today my screen will be mainly VS Code and the Neo4j browser because we'll spend more time in Docker Compose and some diagrams than in any slides actually. So yeah, the outline for today. Um, we'll speak about a small anatomy of a Neo4j Docker container when it's running, how to access and control the container, making usage of volumes, some tips for configuring Neo4j on Docker, installing plugins, but also the life cycle of how Neo4j determines how to install plugins automatically. And we will show how to extend the Neo4j image for having your own plugins inside. As well, depending on time, I can also show a small demo of a Neo4j cluster on Docker. Right, so let's start immediately and go here. So to understand what a Neo4j Docker image is, you need to take the Neo4j Docker file that is provided in the Neo4j Docker repository. So as you can see here, they are using a Debian base image. They are copying the Java binaries from the Eclipse Temurin 17 image. So very important, Neo4j5 runs on Java 17, not Java 11 anymore. They're doing a couple of environments, system commands for creating the right user and the right groups. And then they install Neo4j. They set the working directory, they create some volumes, expose some ports, execute this file, the entry point.shell file, and then they run the Neo4j command that will be passed actually to the entry point. Right? What is important to understand is that a Docker image is actually the composition of many layers. Each line that you see on those in this Neo4j Docker file is actually one layer in the image. So if we look here, right? So here you can see every line is an image, is a layer, right? And actually, if we inspect the Neo4j 5.1 image, right? We will start it here, right? We can see the same representation we have in the diagram, but for the Neo4j image, right? So if I would take this Docker file, right? We start from the bottom. We can see add file here. This is actually taking this line. Then it has 80 megabyte. Then if we go a bit further, we can see here add user. This represents this line. Install the Neo4j binary. This represents everything here. So we can see here is 230 megabyte, so which is the size of the Neo4j tarball, actually. Then all the other commands here, right? They go back to here, right? So all those layers actually compose the Neo4j Docker image. What is important, if we go back to the layer diagram here to understand, is that those layers are read-only, right? They are completely immutable. And every Docker container, so a running Docker container, is composed from all those layers, plus an additional very thin read-write layer on top of those. This thin read-write layer is actually what makes possible for multiple containers, running containers, to use the same base image, actually. So if we look here, right, we can see that if we would have multiple Neo4j containers running on the same machine, for example, they will all be composed of the same image, of the same layers, plus the thin read-write layer. What is also important to understand is that whenever a file has to be modified from the base image, so in the base image, you can think you have the neo4j.conf file, the data directory, everything that we might want to modify will actually, at the time of modification, will actually be copied to the thin read-write layer and modified at that place. This is very important to understand because the performance of the I/O in this read write layer is not very high, right? So it's like low performance I/O. So we will see how to improve this during the session, right? Um, right. So small summary. So image is composed of multiple immutable layer. A container reuse the layers, and also the Neo4j image exposes two volume layers. So very important to understand: data and logs. So if we look here at the and here volume slash data slash logs, right? So this is some hooks that we can use to mount volumes later. All right. So let's take a very small, simple Docker Compose file. Here, simple compose. Here, right? Nothing fancy. So it's the most basic Docker Compose you can have. We just specify the default password for the Neo4j user, and we accept the license agreement because we are using Neo4j 5.10 Enterprise. Very important as well is that you put the yes into double quotes, otherwise it will not be recognized thanks to the awesome YML format, right? So let's start this Docker Compose. So we will use the Docker Compose command, right? Compared to before, we're using the new Compose Go binary. So there is not anymore the dash between Docker and Compose, right? And we will just do upd. So we will launch the container in detached mode. So it will run in the background, right? Now we can check the logs of Neo4j, right? Just for the remaining of this session, I will not, for telling the logs, I will not write the full command. I have a small shortcut here. So here is the Neo4j container started. And actually, if I go to the Neo4j parser, if I refresh here, localhost 7474, we can see that Neo4j is running, and we have the default Neo4j database and the system database. Right? What is interesting to understand is that we can see in the logs already that there are some operations that have been performed. For example, we changed the password for the Neo4j user. We accepted the license agreement. We can also see that Bolt here is enabled on 0000, and as well as the remote interface is set up, which is interesting because normally Bolt is not listening to 000 by default. The server generally would listen only to local interfaces. And so I want to explain what is happening when the Neo4j container starts, actually. Right. So if we look again at the Docker file of Neo4j, here we can see at the end that the entry point contain a file that is called entrypoint.sh that will be executed when the container starts. I will not read line by line, but if you want to have a small overview of what this file is, so it starts here. You can find this in the GitHub repository later. But yeah, so it has a couple of functions. It's very bash heavy, so it's a good also inspiration for some bash commands that you might want to run. Then actually, if we go to the end, we will actually see what is happening. So here, for example, we see that they will set Docker specific configuration already by default if you are running on Docker. So you can see, for example, that they will set the default page cache size to 512 megabyte, the default server listen address to 0000. So this is what is allowing not having to set anything here for the network. So the container will already start listening to the world. Other things, they will apply configuration settings, set the initial Neo4j password, etc., etc. I will not go line by line here. I will just give a small summary later of everything that is happening. So here I have an explanation, small explanation of what the entry point is doing. Right. So first, it will make sure that the directories have the correct permission. So it will use the Neo4j user and the Neo4j group for the permission. It will make sure that if you specify the enterprise edition for the image, you did accept the license agreement Otherwise, the Neo4j container will not start. If you did mount some volumes for data or logs, it will check the file permissions are correct so that it can read and write from those directories. It will load the plugins if necessary. We will go later in the session over the plugins installation. It will set Docker specific configuration. So mainly the lock rotation policy to 100 megabyte of size, page cache size of 512 megabyte, default server listen address 2000, and if also some cluster settings, so it will actually listen to the host name of the container. We will, yeah, we'll apply configuration setting that we provide. Here, we didn't provide any. It will set the Neo4j's initial password. Very important. It will only work the first time the container started and the database was created. I will explain why later. And then it will execute the Docker containers command. Right? So why the setting of the Neo4j password is only the first time is because compared to way before where it was stored in a file, today the configuration of the Neo4j users is stored in the system database. So actually, if you want to have a quick overview of what it would look like, you would have actually in the system database a user node with Neo4j, a hash of the credentials, if the password change is required, and the roles of the user, so generally admin, right? So you cannot change this. This is why it's only permitted on the first time, right? So yeah, this is a small summary of what is happening when the containers start. Now we will stop this container here. Docker compose down and dash volumes. What is doing this? It will actually delete this thin right layer that we saw before, right? So every data that was stored, as I explained, it will copy the neo4j.conf file because we are making changes. It will copy the data directory because the system database is created, the neo4j database is created, etc. So all of this will be in the thin right layer. So we delete this layer here by using dash volumes. Actually, if we don't delete this layer, this is what allows us to restart the container and not lose any data, right, as well. So if we don't explicitly delete the volumes, we don't lose any data, right, until the volume is deleted, either by yourself or if you would use a system prune command, for example, right? So here, all right, let's go to the next section. So accessing the container to understand how the container is running, right? You have the host virtual machine, which is my laptop, but it can be a EC2 instance or whatever, or even a Kubernetes pod. And you have the Neo4j container, which is actually an isolated VM with its own process tree, its own network, etc. Right? So inside that container, we have the /data/logs, which are in the thin layer. And we also have 7687, 7474 ports exposed from the container. And if we look at the Docker Compose here again, right, we can see that we map those ports to the host ports. So this is what is allowing me to specify localhost 7474 or localhost 7687 for Bolt, and it will be routed to the container port 7474 or 7687, right, here. Couple of commands for controlling the container. Let me go here, 4, right? So you can start the container. So let's start the container again here, Docker compose d. And as I said, I will not use the full command for the logs. I have a small shortcut here. So Neo4j is starting, and it will be started, yes, in a couple of seconds. So if I refresh the page, we can see it started. Right. If I need to access inside the container to inspect, we can attach actually a shell to the running container, right? So if I don't specify a name for the container explicitly, when running with Docker Compose, it will actually take the current directory as a prefix, and the name of the service, and one, because you can have more than one instance of the same container. So let's copy this command here. Right, I am inside the container, so you can see we switch from dollar to hashbang. So now if I would just list where I am, LSL, we can see license. We can actually see inside the Neo4j uh, Neo4j directory. So if we look back to the Docker Compose, so let me double click here, to the Docker file, sorry, we can see here, the work dir is the Neo4j home. This is why when we attach a simple shell, we land directly in the work dir. Right? So here we see that we have the data directory that is actually same linked to the /data volume, logs directory, same link to logs volume. We have a couple of other other directories like import, labs, metrics, plugins, etc. Right? So if we would look here in data, let's data, it's cd data. You can see that when the container started, it created all those directories. And as you can see, the ownership of those directories is on the Neo4j user. It's very important. We will see later. Right. There is another thing that I want to mention is that if we look in the startup directory inside the container, we can see there is the entry point, which is actually run when the container starts. There is also Neo4j Labs plugin.json that will give an explanation about later in the session. Right. So if we need to investigate the logs, so we can go to logs here. So of course we can attach a shell inside a container and, for example, tail the query log. Right, so we can see here, those are the queries that are run when you launch the browser to get the statistics of the node labels, etc. But this is not really practical to have to execute a shell inside the container just to be able to see the logs, right? So there is an alternative, right, which is that you can, instead of running a shell, you can actually pass a command that will be executed and will override the default Neo4j command of the Docker of the container, right? So you can go here. Sorry, it will not override it. It will just execute it. So here, if I run this command, I don't need to SSH or to execute a shell inside the container. I can just here have the same debug.log or query.log without having um, logs.query.log, without having to leave my host shell, actually. So it's much more easier because you leverage all the facilities of your own shell, like history, auto completion, etc., your own shortcuts, etc. This is why I have a lot of shortcuts. Right, so now if I need to restart the container, I can just do docker compose, restart, and pass the name of the service. So the name of the service is here, the service Neo4j. So in the same Docker Compose, you can have multiple services, but here I pass the name of the service. Right, so I just do compose restart Neo4j, and if I check the logs, you see stopped, and then it will restart. What is very important is that when you restart, it doesn't, again, it will just restart the container, preserving the same configuration that was provided when the container started the first time. So if you do any changes to this configuration, it will not be applied. So actually we can check here. If I just remove the port mapping definition and I restart the container, I will still be able to access Neo4j because the configuration didn't change at all. Right? So if you want to have the configuration changed, right? So for example, let's say we leave it here. You can do docker compose up-d. What will happen with up-d, mainly with up, is that it will recreate the container with the new configuration, but will preserve again the volumes, the thin right layer that was created when the container started, right? So here, let's try first here. Let's create, for example, a node. Okay, we will now apply the configuration. So let's do here, docker compose up-d. So we remove the port mapping. So what we do expect now is that we cannot access Neo4j anymore from the host, actually. Right, I cannot access it. So now I will reapply the ports mapping. Start again. And what I do expect is that the node I did created to restart before, to recreation before, will still be existing. Right? Let's go back here. And if we look here, we still have our node, Neo4j node that is existing. All right. Now let's check maybe no other commands. So yes, we already discussed docker compose, down, volumes, remove everything. All right. Let's clear this one and move to the next section. Right, mounting volumes. Right. So as we saw, Neo4j expose data in logs, layers. So what we will do now is that we will actually mount a host directory as a volume to data and to logs so that we can keep a copy. The IO will be more performant. And also, if I would use dash dash volume when tearing down the container, it will never be destroyed, right? So it's not a layer anymore. It is really part of the host system. So let's check first at the Docker Compose. You have here volumes. So I mount the current directory slash data to the slash data volume inside the container dot logs to slash logs, right? So if I run this now, docker compose up-d. Oh no, why I have this here? Neo4j started again, but now if I look here on my local directories, I can see that all the data that we saw before was created inside the container. So the system databases, Neo4j database, is now available in my host directory, right? So this means that I also don't need to at all to attach something to the container to inspect the files. I can just now do till f logs query log, and there are no logs because we never opened here. Okay, now we see the logs, right? So now they are available inside my host directory, and if I tear down the volumes, actually, let me create a node here. Create. Okay, use this. Sorry, right? If I would tear down the container, delete the volumes, right? The thin right layer. You can see my data is actually not disappearing. I can keep the data, right? Also, the data is accessible. If you keep in the thin right layer in the in the um, in the Docker layers, it is very hard to inspect the content of the layer, and it is very hard to share the data as well, right? So, so here if I restart the container, it started, I refresh the browser, and I should see my node here. So this will actually be the most confident way of never losing data, is to use properly a volume. Right? So now we'll get on the container again, and we'll move to the next section. Configuring Neo4j. Now this will be very interesting. What I will do, I will comment this line, we will go over later, and I will provide a setting here. So what is important, when you look at the Neo4j configuration in the documentation, for example, in the operations manual, you will have the format that is the same as the neo4j.conf file that you find if you download neo4j tarball, for example, which is dot and one underscore. When you are using Docker environment for configuring the container, you need to first prefix the name of the setting with neo4j underscore, and then you need to replace dots with one underscore and replace underscores with two underscores, right? So we saw in the entry point that it was actually applying the configuration settings from the environment to the neo4j conf file, right? So actually, I will run this now. Docker compose. No, I'm in the wrong terminal here. Docker compose upd. Why? So it did start, and now let's go inside the container and inspect the neo4j.conf file. Right, so I will first check is the name of the container that is running, copy that, and I will do docker exec it sh. It's why I need to go inside the container is because I have nothing that is actually mounting a volume for the conf directory. Right, so if I check here, I go to the conf directory, and I will do cat neo4j.conf. And we can see that our setting is actually added at the end of the neo4j.conf file with the right neo4j.conf format. So it will actually transform back your underscore, remove the prefix, etc., and add it at the end, right? Why at the end is because it makes sure that the latest setting is taken into account, but there is one thing that we will see later about this. Right, so here you can also see that this was done in the entry point, so I explained that the cluster settings are using the container hostname, so you can see here, this is the result of dollar parenthesis hostname, and here our setting is there, right? So what would happen if we would have a Neo4j a conf directory? So let's remove that one. It's from a previous dry run. I will mount a volume here with the conf directory, and I will copy. This is the original neo4j.conf. I will just create a brand new neo4j.conf with the default value here. Right. So we can see at the end of the file, there is nothing. So what we'll do, we'll mount the conf directory to the configuration directory inside the container, and we will see what is happening. And before seeing what is happening, let's find the setting here that we're using here, and neo4j.conf. I will find the setting. I will uncomment it, and I will say instead of it will just be 1024. And maybe I need to tear down the container as well before. Okay. I think I did that in the wrong one. No, I'm in the correct one. All right, so now let's take back the Docker Compose. We have a volumes mounted and we apply a setting, but we also did change that setting in the neo4j.conf file that we will mount inside the container. So let's see what is happening. So we'll start the container. If we look at the neo4j.conf file here, if I look back for that, you can see there is only one setting. So actually, if all setting was uncommented, it will be removed from the conf file, and what you provided in the environment will be appended at the end of the file. Right. So what is happening is that you do have precedence. So first, it will take your own neo4j.conf, and then it will overwrite with what you provide in the environment. All right. So let's tear down the container and let's go to the plugin section, which is one of the Docker Compose down. Very interesting one. So here, okay, plugins. So we saw that there is a Neo4j Labs plugin file in the startup directory of the container. What this file is actually a dictionary of the plugins you can provide in the Neo4j plugins in your Docker Compose here, right? So it will tell, okay, for example, in case of epoch, if you specify epoch, this file is already in the container. So you just need to take the file from the container and execute this setting as well. If you would take n10s, it will actually check the versions file in the directory. So actually, if you look at it here, you can see, then it will check for, okay, for neo4j 5.0, I need to download the jar from there, and it will download the jar, install it, and also apply those settings, for example. So if I do Docker Compose D again here, and I check the logs, right, we can see here, installing plugin Graph Data Science from the varlib, it's already in the container. However, for n10s, installing plugins from, and it fetched the URL from the versions.json file, right? So this is important because often when a new Neo4j version is out on Docker Hub and you try to install plugins, sometimes the versions.json file is not up to date, for example, for n10s, and you will have Neo4j not be able to start because you cannot find the version in the versions.json. So be aware of this because often you have to wait 1 day or 2 to be able to have the plugins aligned as well, right? So, and actually, if I go now to Neo4j and I just do show procedure, show procedures, you can see is there epoch, GDS, etc. Right?
Sorry to disturb you, Christophe, but there's about a minute left.
Yes, sure. And I'm good. So 1 minute left. So let's tear down this container. I will just show a small trick that I found to create files, to create custom images with our own plugin. So we saw this this versions, Neo4j Labs version. So actually, I create my own Docker file from Neo4j Enterprise, and I will copy my plugin jar into varlib neo4j labs myproc.jar, for example. And I will actually, with JQ, modify the Neo4j labs plugins.json that is in the container, and do the same trick that they do. So I provide the location, I provide the properties that needs to be added, etc. So now, if I go here, I just do Docker Compose pubd, right? And I check the logs. We can see that it will install my own plugin. ideally. Let me check the Docker compose. Yes, my proc. So not Docker file here. So where is it? Okay, here applying default values for plugin and installing plugin by proc from actually the directory I created. So it's a neat way. It's very easy to do by just using JQ to add in the original versions.json file the correct things to do. So we just leverage what Neo4j did for their own plugins to create our own images. And that's it. So I think I'm done on time.
All right, what a great session. So much content on Docker. So I think that we had some interest in knowing will this tutorial be available somewhere on GitHub or anything like that?
Yeah, I want to share. Maybe I can. Is my slides still sharing or not?
I can put it up there. It's fine.
Okay, so I will share like all the content of this here into GitHub as well. But also, if you go to bit.ly neo4j-docker-compose, you will land to one of my repositories, which contains a lot of examples of how to run Neo4j in different configuration with Docker Compose. So, for example, 3-core cluster, Neo4j 5 autonomous cluster, Neo4j 5 single with server-side routing at the whole time, read-only replicas, etc. So you will find a lot of examples there.
That's perfect. That's perfect.